Hello everyone. In this video, I'll be discussing about data preparation in Python, which will include how to add an index field, how to change misleading values, how to re-express categorical field values, how to standardize numerical field values, and how to identify an outliner. So let's begin with how to add an index field using Python. So adding an index field can help uniquely identify each record in a dataset, which is specially used for tracking rows after filtering or transformation. In pandas, you can easily add an index column by setting an existing column as the index or by creating a new one. So alternately, if you want to make an existing field, the index. So here is the syntax for adding an index field, which is data.set index. So here set index is used for setting a column as an index, and the name of the column that is set to be as an index column is named as index, and in place.true is used for setting that or putting that setting permanently. So next we have is index fielding in a list Python. Here we will be adding index field in a list. So here we have created a list fruits which includes apple, banana, cherry and date. And here we can access an element using its index. So here we have print fruits index 1. So index 1 represents banana, so banana will be our output. Next we have is update an element using its index. Here we have put fruit to index 2 as blueberry. So when we will print fruits, it will replace value blueberry. So here our output will be apple, banana, blueberry, and date. And next we can add an element to the list, which will its index will be fruits.append elderberry, in which our elderberry will be added at the end of our list. So here will be our output apple, banana, blueberry, date, and at the end elderberry. So next we have index field in a dictionary Python, and we have created a dictionary named student, in which key is ID and value is 1, key is name, and here key is Alice, here key is name and value is 20. And here we will print student name, and our output will be Alice. Next we will print student age 21, and we will print, and if we print that, we will get a dictionary which is ID1, name Alice, age 21. Next we will be adding index field in pandas, and here we have created a data frame which includes key, which is a list, key, and here again a list, and then age, which is also a list. And then we have put here df is equals to pf dot data frame, where pd is panda library and data frame here. And now we set id as our index. So we will put df dot set index, which is used for setting a column as an index, and name of the column is id, and in place will be used for putting that setting for permanently. And when we print our variable df, our output will be in the form of rows and columns, in which we have a column ID, name, and age, and name will include the name of the dictionary that here it is listed, and age will be here as it is listed. And we can access a row using the index, and here the syntax for that print df dot loc, and here is the index value which will print name Alice and age 20. Next we have is changing misleading field values using Python. So data often has values that are incorrect or misleading, like typos or inconsistency in naming. Here we will change some of these values with the replace function in Panda. And here we have created a data frame where pd.data_frame, which will include products and sales in the form of rows and columns. First column will be products and second column will be sales. And here is the syntax for misleading values using Python, and which is data product, which is our first column, is equals to data product dot replace c comma a. So c comma a in this c will replace a, and when we print our data, and here you can see uh, c and a will be replaced in this output. And using replace, we have standardized product by correcting c to a, As I said before, this ensures consistency across our data. Next we have is re-expressing categorical field values using Python. So re-expressing or encoding categorical data, especially for machine learning, we can use mapping to encode these values. And here we have taken our variable as data, pdf.data frame, which will arrange status in the form of a column. And here we have map categories to the number, in which we have taken a variable name status.map, in which we have mapped single to 1, married to 2, and divorced to 3. Next we have taken is status code is equals to data status dot map status underscore map. Here the map function is used to apply a given function to every item of an iterable, such as list, tuple, etc. And when we print our data, single is mapped to 1, married is mapped to 2 as it is listed here. Single again it is listed as 1, mapped to 1, divorced 3, and married 3, 2. Next we have is standardizing numerical field values using Python. So standardizing or normalizing numerical field is crucial in making sure all values have similar range, which have certain machine learning algorithm perform better. Here we will use standard scalar from sklearn. And what is the purpose of the standard scalar in learn? So standard scalar reduces the data size to match its original form. The mean and the standard deviation of x are computed online for later scaling. This method is used to set the value of estimator parameter. And here we have imported standard scalar, in which we have taken variable is equals to pd.dataframe, which will arrange heights and weights in the form of columns. First column will be height and second column will be weight. And we have taken scalar is equals to standard scalar function, in which data height weight is equals to scalar dot fit transform data. So fit transform data function will transform the data and weight into a particular format or the proper format. And when we print data here, it is in the form of mean and standard deviation, which are computed online for later scanning, and this is used to set the values of the estimator permanently or parameters. Next we have is identifying outliers using Python. So outliers can skew data analysis, so identifying them is an essential part of the data preparation. We can use the IQR, which stands for interquartile range, methods to identify outliers. The quartile function in Python is used to calculate the value below, which is certain percent of data in dataset full. So here we have taken variable is equals to pd.dataframe, which will arrange value in the form of a column. We have taken q1 variable, which is equals to data value quantile 0.25. So here quantile function is used to calculate the value below, which is a certain percent of data in a dataset fall. And we have taken 0.25 in the first quartile, which is equals to 25th percentile. And next variable we have taken is q3, which is equals to data value quartile 0.75, which means that 75th percentile of the quartile. Next we have taken IQR, which stands for interquartile range, and our range will be q3 minus q1. Now we are defining outliners. Outliners equals to data values. So data values which means that data values which are less than q1 minus 1.5 multiplied by IQR, where IQR is interquartile range, and here is the bitwise OR, and then data values which are greater than q1 plus IQ multiplied by IQR. And now here we'll print outliners, the values of the outliners. As you can see, the outliner here is 35, as it is said that 35 might be an outliner. So here using the IQR method, we identify 35 as an outliner, and removing or adjusting outliner can improve data quality for analysis and modeling. So this was all about index field using Python. I hope you liked the video. Thank you.